All right, here is the chapter 7, question number 7. The average weight of a professional football player in 2009 was 243.3 pounds. Assume the population standard deviation is 35 pounds. A random sample of 34 professional football players was selected. So we know that the population mean is 243.3. And we know that the standard deviation of the population is 35. And we know that n, or our sample size, is 34. So the first thing we have to do is calculate our standard error of the mean. I know, let's see. So to do that, we will do our population standard deviation divided by the square root of n. All right, now the probability that the sample mean will be less than 227. So in order to do that, we're going to have to find a z-score. Well, so we're going to have an x bar, and our x bar in this case is 227. Then we'll have to find a z-score for that x bar. And to find our z-score, we'll take x bar minus the mean of the sample means, which we'll use the population mean for that, and then divide that by the standard error of the mean. And then to find the probability that it is less than, we're going to do norm.s.dist, put in our z-score, cumulative of true. That is 0.0033. What's the probability that the sample mean is greater than or more than 238 pounds? So here I can just change that to 238. And to find the probability that it is greater than, we'll do 1 minus the probability that it is less than. 81134. What is the probability that the sample means will be between 249 and 256 pounds? So I do this by starting with the higher one, 256. And I get that the probability is that it is less than 256 is 0.9828. So I'm going to call this the p less than 256. And then the p that it is less than 249 is 0.82855. So the probability that it is between 249 and 256 will just be the difference between those two. All right, the last one is to identify a symmetrical interval that includes 95% of the sample means if the true population mean is 243.3. So what we have to do is find the z-score of the upper bound and the z-score of the lower bound. So to do this, the z-score of the upper bound, so if we're going to use norm.s.inv to find the inverse. And then the probability we're looking for, if you think about it, a symmetrical interval that includes 95% of the sample means will be an interval that has 2.5% of the sample means below the lower bound and 2.5% of the sample means above the upper bound, for a total of 5% of the sample means being outside of this symmetrical interval. So the probability then of the upper bound is going to be 0.975. So recognize that that is the probability of something being less than a point or I'm sorry, not the probability, but the z-score of a point that is 0.975 or 97.5% of all possible means, meaning only 2.5% is above. And then the z of the lower, we're going to equal norm.s.inverse. Here the probability will be 0.025. So what we're saying in essence is that between a z of negative 1.96 and positive 1.96 represents 95% of all possible sample means, meaning 2.5% are above. That's why we use 97.5, because only 2.5% above that, and 2.5% below. So that's our z of our upper and our lower. And so once we have that, we can reuse the formula for z-score. We can just reframe that algebraically to solve for a sample mean. So the formula for z-score is that the z of x bar is going to be the sample mean, x bar, minus the mean of the sample means, divided by the standard error of the mean. We've used that on a number of problems in this chapter. We can reframe that algebraically to where x bar will equal the z of x times the standard error of the mean plus the mean of the sample means. So I'm going to put the x bar upper and x bar lower. And so x bar upper is going to equal our upper z times the mean of the sample means. Sorry, no, by this times the standard error of the mean. And that plus the mean of the sample means, which we'll use the population mean for that. And then our x bar lower is going to be our lower z times standard error of the mean plus the population mean. So this gives us a range of, and now we're back into our, by solving that way, we're back into our original units, which was pounds. And it says to round to the nearest pound. So it's going to be 232 pounds to 255 pounds is going to take in 95% of all of our potential sample means. That's it.